Hi, I'm Johana Romero. I'm a research scientist at CIRES NOAA GSR. Today I will give you a brief description of the rapid refresh forecast system with the smoke and dust RFSSD and some results from a smoke simulation. Our motivation is the transitioning of the RAP and HER models to the finite volume cube sphere EP3 in dynamic core. On the left, the three domains. RFS is in blue and it covers the entire North America. The two HER domains, most of the RAP domain at one single domain at 3 kilometers resolution. So our team implemented the capabilities of the smoke component on HER into RFS with new optimizations. So RFS SD has three chemically near tracers, smoke, dust, and cost PM. It also includes hourly fire emissions, which are FRP based, and they come from FRP from the red product, which fuses BS and ghost data. The system also has a fire weather index, hourly wildfire potential or HWP, and it gives us some indication of a fire to develop and also to progress. This weather index is also used in our system to modulate the smoke emissions and FRP during the run time. The RFSSD system is being tested in numerous retrospective simulations and also in real time. So here is an example of the retrospective simulations for the Williams Flats fire case in 2019. And we check first the ability of the HWP to capture the fire evolution. The right-hand side, there's a time series. HWP is in black. And you see how HWP captures the evolution of the fire here, represented by FRP in red. So increases in fire activity at capture going toward the 8th of August, and then both parameters decreases as the fire died down because of the precipitation. The HWP also nicely captured the diurnal pattern of the FRP. There's also a good correlation between the two parameters, 0.66 on the left-hand side plot. Here we are checking the ability of the system to capture PM2.5 enhancement caused by fires. In this case, we compare three emissions scenarios, persistence in orange, same day emissions from the same day FRP in blue, and our HWP modulated emissions. So despite of the overestimations, the HWP modulated, which is in green, is the only one that captures the day-to-day trend in the observations, which is the mean is in the black dashed line. We see the increases in both the gray area and the green blocks from the 4 towards the 8, and then the decreasing after the 8, so on the 9 and the 10. There's a good correlation also compared to the persistence model. So our real-time system is been running for a couple of years now, and we also have an interactive verification tool. So here is an example on the left for the Canadian fires on 2025, and you see how fires are affecting the northeast of the US. On the right is the snapshot of the verification tool. Highlighted the parameters related to smoke. We use different data source for PM2.5, AOD. For instance, we have Aeronet, Modis, Aquanterra for AOD. So here are the web page if you are interested or curious to see how the model compares with the observations. And also this model is scheduled for operational implementation in 2026. Thanks for your time.